Alright, so it's time to actually start learning about chemistry. So we are going to start by talking about matter. I'm sure you've heard about matter before, but we're going to dive in today to what matter is and some common properties that all matter has. So first off, the definition of matter is anything that has mass and takes up space. So essentially matter is everything in the universe except for energy. Energy is the only thing that doesn't actually take up space. So we have matter, the floor has matter, a house has matter, books have matter. Anything that's not light or sound, essentially, um, that's matter. So remember that chemistry is the study of matter and how it interacts, so that's why we need to learn about its properties here. One property that all matter has is that it has volume, because all matter takes up space, so it all has some form of volume, whether it's a solid, liquid, or a gas. So no matter what its state is, two atoms cannot share the same space at the same time. So even though things like gas particles are super, super close together, they'll never be in the exact same space at the exact same time because it's not possible for two things to be in the same place at once. Hopefully you already know this information, but just to reiterate on this, we did labs with measurement. We've been doing it for 3 years, but when we're measuring volume, if it's a liquid, we use units like liters or milliliters, and we measure it in a graduated cylinder. If it is a regularly shaped object that's rectangular, of course, there are other shapes with different equations, but if it's rectangular like a block, you do length times width times height, and that would give you some kind of centimeters cubed. And then if we have irregularly shaped objects, we do it with displacement. So where we put it into the graduated cylinder, let the water rise, and we measure it that way. So it just depends on what we are measuring here. Another property that all matter has is mass. So this is the measure of the amount of matter in an object. So the volume is how much space it takes up. Mass is actually how much matter is there. So no matter where you are at in the universe, your mass does not change. Obviously, we can lose mass and gain mass by eating better or whatever. We tend to call mass weight. That's a pretty common misconception, but that's actually our mass. So if you lose weight, which is what we call weight, you're actually losing mass. So we're going to look at the difference here between mass and weight, and we're going to really get into that second semester with physics, but just to give you a brief overview of the difference between them. So, like I said, mass is the amount of matter in an object. It's never changing except, of course, when you are, if you're losing weight, which again, losing mass, if you get smaller, you are losing mass. But in an instant, it's not, it's going to stay constant. And we measure those in grams, kilograms, milligrams. In the US, we measure that in pounds and tons. Um, what we tend to call our weight units are actually mass units. Mass is the measure of gravitational force exerted on an object. So how does gravity affect that mass that's there? So this depends on location. It's not going to be the same everywhere you're at. So if you go to the moon, your mass is going to stay the same, but your weight is going to change because there's less gravity on the moon. So it's not pulling down as hard on that mass. So we measure that in something called newtons, and we will really get into mass versus weight next semester, but you do need to make sure you know the difference between them now. Another property that all matter has is inertia. So again, this is something we really get into with physics, but all matter has a tendency to resist a change in motion. So an object at rest will stay at rest unless something causes it to move, and if an object is moving, it's going to keep going at the same speed and same direction unless something else acts on it to change that speed or direction. So if a cup is sitting still on a table, it's not going to move unless there's a force behind it that causes it to move. If a soccer ball is kicked, it's not going to change directions or speeds unless a force is acting on it to do so. So, we know that things slow down because obviously things don't just keep rolling forever, but there is friction acting on it, and we'll get more into that later. But inertia is something that every single property has because mass as a measure of inertia. So the more mass you have, the more inertia you have. So the bigger an object, the harder it is to change its motion, whether it's sitting still or it's moving. It's harder to move a bowling ball than a soccer ball because it has more mass. It's harder to stop a semi compared to a regular car when it's rolling, if it were just rolling in neutral, because it has more mass, it has more inertia, and it doesn't want to change its motion. Okay, so that's our properties of matter, and we will get more into that when we do our lab next time I see you.